Welcome to the solution walkthrough for Objective 9, ARP Shenanigans. This is a multi-part solution that involves tricking some malware into redirecting its request to our system, where it will then download a carefully crafted payload to essentially so that we can retrieve contents of a file that is sitting on the infected host. So quite an interesting challenge. It involves the use of Scapy again, and then we'll also be creating, again, our own payload using a sort of a package file. So let's hop right in. So it says here, go to the netwars room and help get access back to a host using ARP, Address Resolution Protocol. Retrieve the document at this location and then answer this following question. So if we go ahead and launch this, I will pull up, I've pulled out all of the hints already for this into this spreadsheet here. So it says we've got these 4 hints. One of them is that to use TCP dump to take a look at any traffic coming from this host that Jack Frost has installed malware on. We can see that the host is then performing an ARP request, and we're going to spoof a response to essentially perform a man-in-the-middle attack, so that the malware essentially thinks that we are the host that it's trying to reach out to. So we're going to tweak a Scapy script to do that. And then the third step is that we're going to see eventually, after we trick the malware into thinking that it wants to talk to our host instead of a different one, it's going to send us a DNS request. Then we're going to craft a response to continue the tricking of this malware to say, the DNS name you're looking for is us, so it's going to resolve to our IP. And then finally, we're going to see also in TCP dump that there's an HTTP request coming through that's looking for a .deb package. So what we're going to do with that package is essentially take an existing package that you would normally install, and then we're going to extract that, modify it so that it executes a command that we craft, and then we're going to deliver that back to the malware. Malware will download it, execute it, or attempt to install it, and with that specially crafted package, we'll then be able to retrieve the contents of the file that the objective is asking for. So as I said, this is a multi-part process, so we're going to go through these one by one as we work our way through this story of essentially getting back access to this host. So the very first thing that in the hints, it says to use TCP dump to view any traffic. So if we hop into here, you notice we got a tmux session with some multiple panes here, and I'll use Control B for the binding and up arrow to go to this top left corner here, and I'll do TCP dump -NNI and then specify the interface, which is ETH0, and we can see that we are getting multiple recurring ARP requests that from the malware infected host that is asking the network essentially who what host is this IP assigned to. So what we want to do is perform a man-in-the-middle attack and basically send a specially crafted response that says our MAC address has this IP, this is actually us, so that it ends up continuing with its actions, which we'll then see as a DNS request. But the first step, we need to create that special response. Inside of scripts, there are 2 example boilerplate scripts, ARP response and DNS response. So we'll go ahead and copy out the ARP response, and we are going to edit it. There's a little bit we need to modify, but for the most part we can keep it the same. We just really want to change the packets or the actual response for this. So what we need to change is some of these details here. So you could see we start crafting this packet. So the destination we need to change to be essentially the source from the request packet. So we'll change this to packet ether at that layer dot source, and then the source then for our response is going to be our MAC address. which they've already created up here. That just gets the MAC address for our system. Next thing for pdest, at the ARP layer, that actually represents the I believe the IP address. So what we can do for this is packet at ARP .psource. So we're basically flipping this because now we're responding. The op.op, that is the opcode. So it for ARP, 1 represents request, 2 represents response. This is a response, so we'll do 2. I actually realized through testing that we don't need any of these for the actual response to still work, so we'll just delete those. Hardware source is going to be our MAC address, so we'll do the MAC addr variable, and then psource is we have the source we're going to want as, so this is where the spoofing comes in. So this request is labeled with a IP address of it's saying give me who has this IP address. So since we are spoofing this and doing a sort of man in the middle, we want to make sure that that P source is labeled as what the malware thinks it is requesting for. So we're going to basically take that directly from the request and put that as our source IP. So we're basically lying there in our crafted packet. The hardware destination, we're going to set as the hardware source from the request packet. And then the IP destination is going to be the source .psource, the IP that this came from. So basically just flipping it for being a response versus request. All right, and then we'll come down in here. One of the things I did is I added a while true, basically just an infinite loop, because we see that this is constantly making these ARP requests, so we'll also constantly respond to them. And so now we can just go ahead and run that, and then we'll see up here that our script starts responding to this and saying that, hey, this is the reply. So we'll go ahead. Sometimes you have to like hold Control-C to escape that. But the interesting thing now, and we'll go, oops. We'll go up here, we'll stop this script. So now we can see we're getting this new sort of information that TCP-dump is capturing. So this is actually a DNS request. It is asking, port 53, that's DNS. It is basically doing an A record lookup for this name. So what we want to do additionally is respond to that, also sort of a man in the middle, and say, hey, we are that machine that you're looking for. Our IP resolves to that name. So so now what we're going to do is come back into scripts, and we'll copy out the DNS response example script. And for this one, we need to also make a few modifications. And what we want to do here is change the this value, the IP address we ARP spoofed. So we ARP spoofed 10.6.6.53. So we want to make that modification. And then inside of handle DNS requests, we need to set up our response packet. So the source is going to be basically the destination of the request, and then the destination is going to be the source of the request packet dot source. Okay, we replace those, so we're good there. Next, so at the IP layer, we need to change these IP addresses. So the destination is going to be the requester. So that's going to be packet at IP dot source. So that'll be basically pointing to the malware box's IP address, and then the source is going to be where this request was being sent originally. So dot destination, DST. And then at the UDP layer, we need destination port is going to be the port that this originated from. So we'll do UDP dot S port, and then the source port is going to be, it's going to be 53, but we can just refer to that as the request destination port. And then so now we need to craft essentially our DNS layer, and this is going to be that a record response. And so we have a few values we need to add in here. So first, starting with the ID. So we'll do packet at dns.ids of the ID for the request, and then we'll do the QD variable, and we'll do packet at dns.qd, and then QR is going to represent 0 for a query and 1 for a response. And so because this is a response, we'll choose 1. And then finally, the AN variable is going to hold our DNS resolution. And we're going to specify the R name as packet at dns.qd.qname. And then the R data we're going to set to the IP address that that our system has, and that is actually defined up here as IP adder. So we're basically responding to this A record request saying that, hey, that name that you're looking up, that's our IP. All right, and I believe this should be all the changes we have to make at this point. So we'll go ahead and write that out, and now we'll get TCP dump going again. We're going to get our ARP response going, and we are also going to open up a new window here with Control B and then parentheses, and we will run our DNS response and then see what happens here. Okay, so let's go ahead and stop this now and take a look at what just happened. So if I scroll up here, I'm doing Control BZ to basically zoom into this panel so that we just see this. But we are getting as you can see here, some traffic going over port 80. Okay. So the next big thing, and one of the hints that we had gotten from the message of the day is that we can run a web server via Python. So Python 3-m. So let's go ahead and set that up. We know that it looks like the web request was coming over port 80. So we're going to need to open even another panel. So let's create make dir. We'll just call this www. We'll cd into that directory, and then this is where our web server is going to be started from. But we can do it with the Python HTTP module, which is built in to Python 3, and start serving that. So now we're basically running a web server on port 80, and let's go ahead and run our DNS response again. And hopefully we get some sort of a request sent to that server, and we can start to look at exactly what that request is. And boom, we do get a request from our malware box. And that is going to it's looking in this path, so pub jfrost backdoor, and then it's trying to download this .deb deb package file. So the final steps that we have left are we need to create a package file because it gave us a hint. It gave us a hint to this link that talks about creating a Linux, basically a package Trojan, using a Debian package and inserting our own payload. And then we have to, have the user install that payload or package, and then it'll execute our commands. And so we're going to go this route to get essentially, command execution, remote command execution on the system. And then we have to serve it at this, this path so that the malware downloads it at the proper path. So First things first, so we're basically following this tutorial that talks about how to extract a Debian package and add in commands in there and repackage it. So to do that, we are going to first, let's go into this window here, make a new directory called package. We're going to copy out specifically the one I used before was the netcat traditional. So let's copy that package into here. And then we're going to run a series of commands here to essentially extract and modify this package. So we'll use a dpackage tool with the -x flag for extraction. And we'll go ahead and extract it here. All right, so now we get bin in the user directories. And at this point, we want to make a directory called Debian. Or you know what? Let me do this first. Let me make a directory called out. And then inside of that, we'll make a directory called Debian all uppercase. Basically, again, just following this tutorial here. So it talks about okay, so first things first, let's go ahead and extract this into out. And then we've already made that Debian directory. Okay, let's go ahead and run the AR command. Which essentially extracts files from archives. So we can do AR -x and then do that, run that on the netcat, which we're then going to see we're going to get some of these archives extracted. And we want to do extract further control .tar.xz, and we're going to extract that into a directory called control. Or excuse me, a file. And then we are also going to extract out another file, which is post-inst or post-install. And then we want to move those into the Debian folder that we created. So we'll move that into Debian, and we'll also move post-install into out/Debian. And okay, so here's the part. We are going to put the command that we want to run inside of the post-install file. We basically want to concatenate it to the end of the file here. Append a command to the post-install file, so our payload will be executed. So let's go ahead and I'll show you the command we're using. So I actually originally, when I went through this challenge, I tried to use a reverse shell, and I was having a lot of issues with that. It was actually calling back and connecting to my netcat listener, but it was not it wasn't interactive. I couldn't actually execute any commands. So I got really frustrated with that, couldn't figure it out, and I realized, well, hey, the objective is only asking for the contents of a file. So let's just have it let's just have netcat on that side dump the contents of the file into my listener, and then I'll save that to file, and that's all I have to do. And that actually worked out flawlessly. So here's the command for that. We're basically going to echo this netcat command. So we're netcat, and we are essentially feeding the contents of this file into netcat, which is then going to pass it over to our IP at this port. Now I do need to check, because this is from my old notes, but we want to make sure we have the right IP. So for that, we'll do IP space A, and we can see that we're sitting at 10.6.0.2. So that command will actually work just fine. So I'll go ahead and copy this again. So again, we are echoing this command and appending it to the end of this post install file. And this is basically just using netcat. So what we're doing is installing netcat, and then we're going to use it after we install it. So netcat and then dash W3, that's basically specifying, I think, the file size. Let's take a look at the man page here. Timeout. Okay, that's the timeout. So basically, if you were to transfer like a large file over netcat, you would want to increase that timeout. But 3 worked just fine, and you'll see later it's a pretty short text file. So if you were transferring like videos or something, if you decide to do that over netcat, you would want to step that timeout up quite a bit. So, all right, so the next thing we're going to do is essentially repackage this into a deliverable and installable Debian package. So for that, we'll use the dpackage-deb command with the --build flag, and then we want to specify the directory with all those files in it, which is out. And now it says that we are building package netcat-traditional in out.deb. All right, so that's our resulting rebuilt package, which is now weaponized. And what we want to do is in our I'm going to write make-dir-p, and what that does is we can have a string of nested directories, and if those don't exist, it's going to create that for us. So inside www, we want to create the path, this path here, so that when we serve this as a web server, we have these directories, and it actually aligns with what the request is looking for, and it'll be able to get our file. So we need to do, since this is our top level root directory, we need to add pub, and then we need to add the jfrost directory, and then we need to add the backdoor directory. And so again, that -p is going to, instead of us having to do multiple make-dir commands, that -p is going to allow us to create those directories all at once. All right, so now over here, what we can do is we're actually still going to run our Python server from the same spot. And then here, oops, we want to copy out.deb to essentially that directory. So now when the malware goes and makes a web request for this path, it'll be able to find that file. And one thing I did mess up is we need to make sure that we rename out-deb to serv_amd64.deb, and we need those file names to match for the web request to work properly. Okay, so now I believe we are ready to actually give this a run. And to run you through all the steps again, we are ARP spoofing so that the box thinks that we are the IP address that it's looking for. Then it's going to send a DNS request to us, or just a DNS request out, and we're going to respond to that DNS request saying that that A record, that name that you're looking for, is actually associated with our system. And then it is finally going to send a web request for this file, and then it's going to download that Debian package file and install it. And since we've weaponized our package to have a command in it to execute upon install, it's then going to feed in the contents from the file that we're looking for the challenge, and we'll be able to see those contents. The last thing we have to do is set up a netcat listener to actually receive that information that our weaponized payload is going to send over. So I'm going to open up, actually I don't need to open up another one, but what I'll do here is set up the command for the listener. And so what we can do is netcache-lp, and that's to tell netcat to listen on a specific port. And again, our payload has the port 1 through 7, so we want to make sure we're listening on that port. And then what we're going to do is send that output to a file out.txt. If I hit enter, it'll now start listening, so it's ready to catch that output when the malware host runs it. Okay, so it looks like we're sending the ARP response already, so we want to also send the DNS response, and then we should get our data. Okay, so it sent that. We got the web request. Looks like it was a 200 now, which means that it successfully was able to find that file. And now netcat just timed out, which is a good thing. And if we cat out.txt, boom, we actually get the contents of that file from that system. Perfect. So to solve this challenge, it is asking for basically who recused themselves from the vote. So I'll do search for vote here. So basically we have to read through this here. Oh, here we go. Nope. Search for recuse. There we go. Tanta Kringle recused herself. Okay, so this is the answer to the problem. So go ahead and copy that, exit, and then we can submit that as the solution for this challenge. Boom, that's how you do it. So that is quite a complex, multi-step process to solve this one. So if you do have any questions, let me know. Otherwise, we'll catch you in the future videos.